Hopefully you've downloaded the fill in the blank notes for this PowerPoint. So we're talking about specific heat capacity. Okay, so imagine a hot day in Arizona in your backyard. You have a metal barbecue and a glass of water. What would you rather put your hand in? Well, of course, we all know it's water. Well, why is it that the water and the barbecue are sitting in the sun? It's 110 degrees out. Why does the water stay cool relative to the barbecue, right? You're going to burn your hand on the barbecue, but putting your hand in the water is sometimes refreshing, right? Especially if it's a swimming pool. So it has to do with the heat capacity of the metal that the barbecue is made out of and the heat capacity of water. And while I'm going through this and through the examples, if I'm going too fast, just pause the video. Okay, specific heat capacity. So what is it? Right, it says the quantity of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. So the quantity of heat required, we're talking about energy. So how much energy is needed, and the energy kind of is transferred into our substance by the heating process. So how much energy is required to raise 1 gram of our metal barbecue by 1 degree Celsius? Well, it's not that much actually. Compared to water, well, how much heat or how much energy is required to raise the temperature of 1 gram of water by 1 degree? Well, relative to that barbecue, it's usually about 10 times more, roughly, depending on the metal, about 10 times more energy is needed to raise the temperature of water 1 degree than it is to raise, a piece of metal that you might find in a barbecue by 1 degree. So the units there are joules per gram times degrees Celsius. So it's the quantity of heat required. Well, we measure energy and heat in joules. So that's what that J stands for, joules. And then, of course, we measure mass in grams and temperature in Celsius. So that J is for joules. Okay, so here is kind of that example of what I was telling you. Look at iron and copper. They're 0.4 and 0.3, but water has a specific heat capacity of 4.184. That's roughly, compared to them, approximately, right, 10 times larger. So it takes 10 times more energy in joules to raise 1 gram, 1 degree Celsius. Okay, we're going to do some equations. Some example problems. Whenever you do your work, make sure you write down that formula first without putting in any numbers. You need to do that on any part of an essay question in a test or a final exam, and you need to do it on every homework problem where you use that equation. Always write down the equation first if you want to get all your points. So what does all this stuff stand for? Right, Q is the heat transferred, as I said, in joules. Sometimes you'll see it as a capital Q instead of a lowercase q. That's totally fine. It doesn't matter. M, of course, is mass. We always want to be in grams. C, that's going to change in our equation, right, based off of the substance. That's the specific heat capacity. And our delta T is temperature. And sometimes when people see a change in anything, they always just think it's the difference. You can't just find the difference. It has to be the final minus the initial. Because let's say you had a final of 20 and an initial of 80. Well, that answer comes out to be negative 60. That means that energy was released in this case, right? Your substance was cooling down, not heating up. Or if it was the reverse, right now it's positive 60, so that your substance would be gaining energy. Anytime your system, the stuff that you are concerned about, anytime, which normally in this case is going to be our object that we're talking about with our specific heat capacity, if it loses energy, which often we can see it by getting cooler, that means that the energy is leaving our system or leaving our object, and that means it is categorized as exothermic. When energy is entering our system, so the sun is beating down on that barbecue grill or the water, then it is endothermic because it's gaining energy. Energy is coming into your system. So those are two vocab words that you need to know. Exothermic, energy is exiting your system. Endothermic, energy is coming into your system. Okay, so I'll stop here just in case you want a break. Look at the next video for the practice problems.